Hello everyone. I'm sure that many of you have been on an airplane before, and you may have wondered what goes on up front in the flight deck where the pilots sit. Today I am going to answer the question, how exactly does a pilot fly an airplane to its destination while doing a simulated flight from San Francisco, California to Washington, D.C. in this Boeing 757 aircraft? But before I get into the systems of the aircraft, let me tell you a little bit about this airplane. The Boeing 757 is a single-aisle, medium to long-range jetliner designed and built by Boeing in the late 1970s and early 80s. Its first flight took place in 1982, and the last 757 was built in 2004. It has the same fuselage cross-section as the 737, which is Boeing's most popular jetliner. On the 757, however, the landing gear was raised in order to allow for bigger and more powerful jet engines to be mounted underneath the wings. This 757 is equipped with Rolls-Royce RB211 engines, with each engine having the capability to produce up to 40,000 pounds of thrust. The other engine option for the 757 is the Pratt & Whitney PW2000. Right now we're going to go under the wings. These things over here that stick up from the ends of the wings are called blended winglets, and what they do is they reduce the formation of vortices at the wingtips, which causes a lot of drag, and the winglets reduce this drag by a significant amount, allowing the airplane to burn less fuel and increasing its range. And they also make the airplane cheaper to operate for the airlines. This over here is the tail number of the aircraft. It's November 17105. And over here is where the APU, or Auxiliary Power Unit, is located. What the APU is, it's a small turbine engine that provides electrical power and compressed air, which is known as bleed air, to the aircraft systems on the ground while the engines are not running. The APU can be accessed through these doors over here. So let me just open them. So here you can see the APU. I'm sure many of you may wonder what this compressed air or bleed air is used for. One of the things it's used for is it can be used to pressurize the cabin when the airplane flies at high altitudes. It can also be used to start the engines while the airplane's on the ground, and it is used to power the anti-ice systems on the wings and the engine nacelles, which is very important because any ice formation on the wings will change the aerodynamic characteristics of them, and that could result in the aircraft stalling or falling out of the sky, which is something we do not want. And here is the nose of the aircraft. So now let's go inside to the flight deck and begin to power the aircraft up. So when powering up the aircraft, the first thing we have to do is go to the overhead panel, which is where the pilot can control all the different aircraft systems. The first thing we have to do is turn on the battery. The battery provides enough power to run enough of the aircraft systems so that we can power the rest of them up. The next thing we have to do is turn on the standby power. Then we have to go to our emergency lights switch, which ensures we have to ensure that they're in the armed position. And what this will do is, if the aircraft loses power in an accident, for example, then the emergency lights will automatically activate. The next thing we have to do is turn on ground power or external power, but before we do that we have to connect the ground power unit or GPU, and the GPU is this thing over here. It's a cart with a generator in it that is used to provide electrical power to the aircraft on the ground when the engines are not running, and it can be plugged in behind the landing gear over here. So now we have to activate external power. This yellow light means indicates that it's available. So, and now it's on. And as you can see, all the screens have just turned on. The next thing we have to do is turn on the aircraft's navigation systems, which this aircraft is known as the IRS, or Inertial Reference Systems. And what these are is they're very sensitive gyroscopes that are used to determine the aircraft's position in the world. And this information is then fed to the flight management system, which are the flight computers used to guide the airplane, which in turn is fed to the autopilot, which will fly the airplane along the flight path programmed into the flight computers. So to turn on the IRSs, we have to select the nav position for each one of them. And nav stands for navigation. So, and then we go over here to this thing called the CDU, or Control Display Unit. What this is used for is it allows the pilots to interact with the flight management computer, or FMC, which is where the pilots program the route that the airplane has to fly. When the aircraft is first started up, this screen appears over here, and it tells them the aircraft model, the 757-200 in this case, the engine type, the RB211 535 E4B. And now we have to go to the position initialization page, and this is where we enter our IRS position, which is just a set of coordinates. This aircraft is equipped with a GPS unit that determines these coordinates for the pilots, and all they have to do is just select them and input them over here, and this will cause the IRS to align. And as you can see, the flight instruments have appeared on these screens. On the actual aircraft, it can take up to 10 minutes for the IRS to align, but in this simulation it has been shortened to just a couple of seconds. So the next thing we have to do is program our route into the aircraft computers. This is where we enter our origin airport, which is San Francisco, or KSFO. Our destination is Washington Dulles. It's KIAD. And our flight number, we'll just choose 7572 for this flight. And now we have to create our flight plan, and I'll show you that in the next video. So I'll see you then.